Hey guys, we're going to go over the pendulum problem that we kind of presented yesterday, as well as talk a little bit more in depth about the different types of energy. You guys have talked today in your notes about different forms of energy and the particular ones that we want to look at. One thing I'm going to do today is I'm going to combine the different energies that we kind of lose in our system as dissipated energy. Typically, that's mostly thermal. Sometimes it's going to be acoustic energy as well. Let's take a look at the pendulum as it goes through here. Okay, so you guys have seen it go back and forth. What we're going to look at is when it's way over here, here, and then back here. And then we're going to do another swing back here and back here again. Okay, so let's draw this on the board at 6 different locations. We'll kind of show you what this looks like. All right, so the first thing is when the pendulum's like this, okay? The next one's going to be when the pendulum is like this. Next one's going to be pendulum like this, okay? Then we're going to have the pendulum swinging back again, and then pendulum swings back this way. Now you guys know from class yesterday that the pendulum never makes it all the way back up to the other side or back. So we did that little trick where if you hold it against your nose and let it go, you can kind of do that bravery test. It's not going to come all the way back up and hit your nose because some of the energy we know is being lost in the system. Remember, we talked about open and closed systems. Open systems are where everything stays in the system, all the energy stays in there. Or sorry, closed systems. And then open systems are where energy is sometimes lost to stuff outside of our system. So for me, in this example, I'm going to say that the system includes only the pendulum. So it's not even going to include the earth underneath the pendulum. This one's going to be pretty easy. We're going to do it the other way in just a second. Okay, so remember, the first thing you have to do is determine what your system is. So first here, I have just the object that's standing still up here. It's got gravitational energy because it's above its lowest point that the pendulum's going to go. So the lowest the pendulum's going to go is going to be right here, okay? But it's a little bit above that right now. So the only type of energy I have is gravitational potential energy. So P-E grav, 100%, okay? Over here, it's at its lowest point, so it doesn't have any gravitational potential energy. What it does, though, is it's moving, so that's mechanical kinetic energy. Okay? Now, when we get to the other side, and this was actually happening a little bit right here, we've been losing tiny little bits of energy to acoustic energy and to especially the thermal energy with internal friction inside the string and everything like that. So we would have a tiny little bit of Ke dissipated, okay? Again, that's going to be some acoustic and some thermal energy, but we're lumping them together to call them dissipated energy right now. Now here, our mechanical energy is being converted into potential energy due to gravity. So right here, we're going to have mostly Pe grav, all right? And then after that, our dissipated energy is getting bigger. So we're going to make it just a little bit bigger, okay? Now everything is kind of swinging back now. It's kind of gone back down to the middle. So we're going to look like this, except we have even more dissipated energy, all right? And then this other type of energy that we have right here, remember it was up at this higher position, it's gravitational energy, it swings down. Now it's going to be at down over here. Now it's going to be at kinetic energy again, mechanical kinetic energy. And then lastly, it goes up to that other side. Remember, it doesn't get all the way there because we've had even more dissipated energy. And this is exaggerated. Remember, these are qualitative, not quantitative. Sorry. It's not big enough. And then since it's at that higher position again, this is going to be our potential energy due to gravity. Now, if I really wanted to, I could make the bottom of the table part of my system. If I do that, then I have gravitational potential energy even at this point as well. So let me redraw that. And again, I'm redrawing it as if I considered the tabletop as part of my position. So it could potentially fall a little bit farther. This is the way I would normally do it. A lot of you guys did it this first way yesterday, okay? So we would have PE grav when it's in that highest position. Again, this is the position when it's like that. And then over here it's swinging down. We have some gravitational because we are above the ground, so I'm going to add that in here. PE grav. A little bit of dissipated. And then mechanical energy. Over here, more mechanical energy, same amount, or sorry, more dissipated energy, and then the same amount of gravitational energy that we had in this one, because it's at the same height. Okay. Over here, when it's in that bottom position, okay, so far we've started out here, gone to here, over here, now it's swinging back again. We're going to have that same little amount of gravitational energy that we had over here because it's at that same height, okay? So let's add that in there. And then this same amount of mechanical energy, or sorry, dissipated energy. And then at the very last position over here, it's going to look the exact same as this one. So okay. All right, let's take a look at another example here in just a second. Okay, this time we're going to take a look at an example of a guy jumping on a trampoline, and I'm not going to get too much into the fine details of this one, but we'll go over some of the major stuff. Guy is up in the air. Let's say he's jumping from a really high place. Who hasn't had that great idea before? Falling still, okay? He is now down at the very bottom of how far the trampoline will let him go. It has pushed him back up, and then we're back up into the air, okay? We're going to pretend that this one is a completely closed system. My system is going to include the guy and the trampoline and the ground, okay? So there's going to be some intricacies I want to point out here to you guys, all right? In this one, pretty easy. He's not moving yet. He is above the ground, so this is all PE gravitational, okay? In this one, he's about halfway down, so he has half gravitational energy and then half mechanical kinetic energy because he's moving, okay? Down here, when he hits the trampoline, he's not moving anymore, okay? He's at the very bottom of the trampoline. He has a tiny bit of gravitational potential energy because he's a little bit above the ground, so I'll give him a little bit of PE grav, okay? But this stuff right here, this is all elastic energy which is stored in the trampoline. So this is going to be PE elastic, okay? After the trampoline has pushed him back up in the air, we have this going on again. It's going to be the exact same as this one. So he is getting higher. He's got some gravitational potential energy, okay? And he's moving, so he's got mechanical kinetic energy, Ke, mechanical. And then right here, he's back up to his highest height again. All right, so he is fully gravitational potential energy. Now, if this problem was not a closed system, if we were considering energy leaving the system, there's two options you could do. You could add that dissipated energy in there, so you would have a dissipated energy, especially probably starting right here, and it would just stay there, okay? It would be the same size of dissipated energy here, and the same size pi slice here, and the same pi slice here. Or another thing that we're going to talk about later is you can actually, if we have energy leaving the system, your circle, your pi slice can get smaller, okay? Hopefully this helps you guys review it. If you have any questions, feel free to email me or tweet me, and then I'll try and get back to you. So see you later. Have a good day.